Action.
Hello viewers, today we shall continue with our lessons in SSS Physics. In the previous lesson, we saw that an important aspect of physics involves quantities that we have to measure. These quantities were placed under three categories. 1. Fundamental quantities. 2. Derived quantities. And 3. Dimensionless quantities. In this lesson, we are going to look at these quantities that we deal with in physics in another way. Specifically, we are going to look at another mode of classifying quantities in physics. By the end of the lesson, you should be able to 1. Define a scalar quantity and a vector quantity and give examples of each. 2. Classify quantities into scalar and vector quantities when given a list of quantities. 3. Define some important scalar and vector quantities. 4. Distinguish between acceleration due to change of magnitude from acceleration due to change of direction. 5. Establish the fact that any change of velocity, whether it is of magnitude or of direction, constitutes an acceleration. 6. Explain why a moving body in a circle at a constant speed is said to be accelerating. And 7. Represent vectors and the negative of a vector and the scalar multiple of a vector graphically. First, we would want to identify those quantities in physics under the previous topic, dimensions, that have only magnitude. That is, those that only address the question, how much? These are referred to in physics as scalar quantities, or scalars for short. Can you give some examples of these quantities identified only by magnitude or by assigning some number to them? Did you think of the following as examples of scalars? Mass, distance, speed, temperature, density, relative density, refractive index, area, volume, work, or energy. They are some examples of scalars. Look at them carefully, trying to see whether you can assign numbers and units to all of them. You would have realized that you can assign numbers to all of them. None of them has direction. To some of the magnitudes or numbers, you can attach units. This shows that all are scalars. Some of the quantities are fundamental since their units are fundamental units. Some of the quantities are derived, as can be seen from their units, and yet another group can only be identified with magnitude but no units. These are the dimensionless quantities. This means that a scalar quantity can be fundamental, derived, or dimensionless. Can you group the examples listed under these subgroups? And let's see. You can also attach some units where possible. Mass, distance, temperature, all grouped under fundamental quantities. Speed, density, area, volume, and work or energy, all grouped under derived quantities. Under dimensionless quantities, we have relative density and refractive index. Having identified scalar quantities, that is, quantities which have only magnitude, let us look at the second group of quantities that have both magnitude and direction. This means that apart from magnitudes or numbers, some direction will have to be attached to them to make them complete or meaningful. This class of quantities is referred to as vector quantities, or vectors for short. Can you give some examples of vector quantities? Did you think of the following as examples? Displacement, velocity, acceleration, force, momentum, moment, impulse, electric field intensity, and magnetic flux density. There are some quantities in the list you have not yet met, and there are many more that you will discover as you progress in the SSS course. This applies to scalars as well. All quantities referred to as vectors can be specified by stating magnitude as well as direction. Let us take some of them for illustration. First, let's consider 1. A speed of 20 meters per second. And let's consider 2. A velocity of 20 meters per second northwest. 1 refers to the distance covered by a body per unit time as it moves from one place to another place. And this is speed, a scalar quantity, as it has only magnitude. 2 refers to the distance covered by a body per unit time as it moves from one place to another in a specified direction, specifically northwest in this case, and is a vector quantity as it has both magnitude and direction. Let's take another example. 1 20 meters and 2 20 meters east. 20 meters refers to a distance of 20 meters between 2 points. Perhaps a distance of 20 meters from a given point, example A, no particular direction is specified, in which the 20 meters should be measured from A. It is a scalar as it has only magnitude. The diagram shown on the screen, not drawn to scale, shows possible ways of obtaining 20 meters from A. And 2 refers to a distance of 20 meters in the east, or it is 20 meters due east. It is a distance of 20 meters east of a given point A. It is 20 meters measured in a given direction from A. It is a displacement as shown on the screen, not drawn to scale. This is a vector since it has both magnitude, that is 20 meters, and direction, east. I hope it is now clear why displacement, velocity, acceleration, and force are vectors. Let us now attempt to define some of these basic quantities. Distance. This is the interval between 2 points in space. Example, 20 meters from A, or the space between 2 points A and B. Having fixed A, B could be anywhere 20 meters from A. Now let's look at the displacement. Displacement is the distance moved in a specified direction. Example, 20 meters north of A. We may also want to look at speed, which is the rate of change of distance moved with time. For example, a car may move at a speed of 100 meters every second. Its speed is then said to be 100 meters per second. Velocity is the time rate of change of distance moved with time in a specified direction, or the rate of change of displacement with time. For example, if a car covers 100 meters every second while it moves towards the west, its velocity is 100 meters per second west. We would also consider acceleration, which is the rate of change of velocity with time, or it is the rate of change of speed with time in a specified direction. Note that velocity is speed in a given direction. It must be noted that it is only when the velocity of a body is changing that we can say the body is accelerating. Therefore, when the speed of a body changes while the body moves in a specified direction, velocity is changing, and the body is said to be accelerating. Also, when a body's direction changes, as the speed remains the same, the velocity is changing, and thus the body is accelerating. This is because velocity is a vector quantity and having magnitude and direction. It can change either in magnitude or in direction to bring about an acceleration. To understand this concept more clearly, let's consider the following cases. Let VA and VB denote two different velocities of a body. Let VA, that is velocity of A, equals 20 meters per second north of west, and velocity of B, VB, equals 25 meters per second north of west. VA is a particular velocity specified by a magnitude of 20 meters per second. This is the speed and also by a direction northwest. VB is another velocity with speed 25 meters per second, magnitude, and direction northwest. A change from velocity 1 to velocity 2 is due to a change in speed, that is magnitude, from 20 meters per second to 25 meters per second. It is thus a change of velocity and thus constitutes acceleration. This is an acceleration due to a change in magnitude, that is speed. Let's represent this by A. Now let us consider another case. That is 1. Velocity A equals 20 meters per second northwest. And 3, velocity C equals 20 meters per second southwest. As explained earlier, 1 and 3 are different velocities, each specified by a magnitude that is speed, as well as a direction. A change from velocity 1, that is VA, to velocity 3, that is VC, is clearly due to a change in direction from northwest to southwest. Since a change from velocity 1 to velocity 3 is also a change in velocity, it constitutes an acceleration. This acceleration is due to a change of direction. Let's represent this by the letter B. From what we have discussed now, it shows that acceleration is a change of velocity and can be due to a change of magnitude or a change of direction. In conclusion, any change of velocity, whether it is of magnitude or of direction, constitutes acceleration. Now, consider a body moving in a straight line. This means that its direction does not change. For the body to accelerate, it means the change in velocity must come from a change in speed or magnitude. Therefore, if a body moving in a straight line has its speed increasing, it is said to be accelerating. On the other hand, if its speed is decreasing, it is said to be decelerating. Deceleration represents a negative acceleration. Now, consider another body whose speed cannot change. This body can accelerate if its direction changes. That is, if the body is not moving in a straight line. Suppose a body B is moving in a circle at constant speed. Since it is moving in a circle and its speed is constant, its acceleration is due to the fact that its direction changes, as shown on the screen. The special case of acceleration due to the fact that the body is moving in a circle is centripetal acceleration. We shall look at this acceleration more closely later in our course when we come to study circular motion. Other vector quantities include force. Force is a vector quantity because apart from having magnitude, it has direction. A force needs direction for complete specification. A force of 20 newtons will not have complete meaning if we do not know what direction it acts. The direction in which the force acts must usually be stated. This notwithstanding, it is assumed that a force would always act in a particular direction and is considered a vector. Momentum, normally represented by P. This is the product of the mass and velocity of a body. Suppose M equals mass of a body and V equals the velocity of the body. Then momentum P equals mass times velocity. Since M is a scalar quantity, momentum is a scalar multiple of a vector, and it's a vector. Scalar multiples will be considered soon. Now we would want to turn our attention to how to represent vectors. A vector has magnitude and direction. A vector is usually represented by a straight line with an arrow or arrowhead on it. The length of the line represents the magnitude of the vector. The arrow represents the direction of the vector. Let us represent a few vectors. On the screen, we have vector A, that has a line and an arrowhead which shows the direction of the vector. And vector B also has a line and an arrowhead which shows the direction of vector B. Let us now consider the negative of a vector. The negative of a vector is a vector of the same magnitude as the vector in question, but having an opposite direction. Some are as shown on the screen. Let us now consider equal vectors. Two vectors are equal if they have the same magnitude and direction, or are parallel, as shown on your screen. Let's now consider scalar multiple. This is a product of a vector and a pure number. The number is usually a scalar. For example, if a small a with a short line under it is a vector and a small m is a pure number or scalar, then ma is a scalar multiple of a. Thus, ma is m times a with a short line under it and in the same direction as a. Thus, 2a is a vector in the same direction as a, but having twice the magnitude of a. Also, momentum equals mv is a scalar multiple of velocity v. Being a scalar multiple of a vector, momentum is a vector. Another example is impulse, ft, where f is a force and t is time. Vectors are usually represented in small letters and in bold characters, but in writing, a wavy line called a tilde is usually placed under the letter to signify the fact that it is a vector. In this program, a letter usually small, underlined, and in bold character will be used to denote a vector. Examples are shown on your screen. That is A, small a with a small line under it, small b with a small line under it, C with a small line under it, and D with a small line under it. In this section, we have learned about scalar and vector quantities. In your studies throughout your course, look out for more examples of each. What are scalar quantities and vector quantities? Define the following: distance, displacement, speed, velocity, and acceleration. Explain why a body moving in a circle at constant speed can be said to be accelerating. Choose any vector and represent it in a diagram. Represent the negative of this vector. Also, represent in diagrams different scalar multiples of this vector. Now, viewers, I would want you to take these ones down and see how best you'll be able to answer them. A. What are scalar quantities? B. What are vector quantities? C. Give at least 4 examples of each. This is where we end today's lesson. I hope you've enjoyed it. Till we meet for the next lesson, it's goodbye. It's goodbye.